Hello everybody and welcome back, and sorry for cutting this tutorial. Now I had to switch to my laptop in order to show you this, since my Kali Linux machine couldn't really recognize the kernel as being Linux kernel. Now, and there is a library that we need to import in our DNS spoofer program in order to get this to work. Now the library is called netfilterq. Let me just show you how we can install it. You can install it with this command, pip install netfilterq. You let this run and it should install the netfilterq library for you. Then we will be able to actually use this program, or basically to run this program once we actually code it. So just let this run. What this will do is it will install the library for you. If you want, you can actually use the Python 3 version as well. So for some reason it's getting an error. Okay, so let us try with Python 3. So pip3 install netfilterq. It gets the same error, but if I run Python import netfilterq, it is actually being imported, so don't worry. This error is something that I encountered before as well. So all we have to do right now is nano our program, which we will call dnsspoof.py. Let us start off by actually putting our usual line, which is the hashtag and then exclamation mark / user bin Python. And after that we want to import two libraries. One of them is our netfilterq library and the other one is scapy.all library. So import netfilterq and we can import scapy.all as scapy. So simple as that. What we want to do right now is actually make our queue, which is actually used in order to make a queue number from the IP tables. What this will allow us to do is actually sniff the packets and redirect them, or redirect the users to our own web server. So what I will do right now in this program is I will redirect the users to the web server on my Kali Linux machine, which is running at the moment on my main PC. And what I will do is, in my program on my laptop currently, all I will do is specify the IP address of my Kali Linux machine. So don't get confused, I'm using the web server Apache 2 from my Kali Linux machine in order to redirect them to the fake Facebook page that we created previously. So in order to create the queue which I was talking about, you don't need to specify this command. You can call it queue equals netfilter, which is the library that we installed, netfilterq.netfilter. And make sure to specify the Q right here capital, since this is a function and it will not recognize it if you put small letters. And all you want to do, since you added the object to this Q variable, you need to bind it. So Q.bind, and in between the brackets you need to specify the Q number, which we will specify to be 0 right now. And what we will do is we will actually process packet. Now the process packet is a function that we will code in order to change our packet and redirect the user. So let us call it process underscore packet, close the brackets, and all you have to do is run the queue. So queue.run and open and close brackets without any parameters based to that. So all we have to do right now is actually code the function itself. We can do that with our def command. So let us make a function def process packet. Once again, make sure you call it the same as you called it in the bind statement right here. And all you want to process is the parameter packet. So we want to actually use the packet and make changes to it in order to perform our task. So what we want to do first of all is actually get the payload from that packet, since that payload is something that will actually contain the DNS request or the DNS response. In order to do that, we can use a function called getPayload, which will allow us to get the payload from a certain header that we will specify. So let's call the variable that we want to put the payload to scapy underscore packet. Scapy underscore packet equals scapy.ip, which is the IP header from our packet, which must be there if we are waiting for the actual DNS response and request packets. And all we want to specify between the bracket is the packet that we are using, which is this packet right here, and the function .getPayload, so packet.get underscore payload. underscore payload, open and close brackets, since this is also a function, and here we specified our scapy packet to have the payload from the received packet. Now if you want to, we can actually just print the packet itself, so just to check it out, so print scapy underscore packet, and let us see what will happen. So let us run this, chmod +x dns spoof.py. Let me just enlarge this so you can see a little bit better. Zoom it once again and run the packet itself. Okay, so we ran the program, and if I just go and refresh this Google page right here, nothing happens. But if I go to a certain website, for example, we get nothing printed out yet. Okay, so let us actually get something to print out. Let me just close this right here. Nano the DNS spoof. And let me check this out right here. Okay, so the next thing we want to do is actually check if our packet has a layer for the DNS request or response. So how we can do that? I just noticed that we got disconnected from the internet, and the reason is probably these 3 lines right here. So there is a certain thing that we need to run in order to get this to actually work. That's why we couldn't print any packet. You need to actually create this queue, you need to flush your IP tables, and you need to forward some of this stuff in order for this program to work. But don't worry, we will do all of that later on. For now on, all I want to show you is actually how to create this program, and then we will be running it. So print scapy.packet. What we want to check right now is if this packet has layer DNS. So we can do that with the if our scapy_packet dot has layer, which is a function that we used in the previous video. And the layer that we actually want to get right now is the DNS response. So it is much better to actually intercept the DNS responses than to actually intercept the DNS request. So it was much faster. So what we want to actually get is the DNS response. Now, in order to specify just the DNS response, in the brackets, all you need to type is scapy.dnsrr, which stands for basically response. Now, the DNSRQ stands for the request, but make sure to specify in the capitals DNSRR for the actual response. And now we need to type this or to tab this, and in order to get the query name for our actual response or request, we can just put it in a variable. Now the query name is basically something that the user typed in their Google search bar. So let me just show you. If you, for example, go to the Firefox and you just type facebook.com, that will be a query name which will be specified under the queue name in our DNS request. And then what we want to check out in our program is actually if there is a certain web page in that query name. So first of all, let us put it in a variable called queueName equals scapy_packet. So from our scapy packet, let me just write it correctly. So scapy_packet. From the DNS request, so DNSQR, which basically stands for the DNS request. What we need to get is actually the field queueName. So let us type it like this. If scapy packet has layer scapy DNS response, the queueName will be the scapy_packet from the request queueName. We are looking for this field, so let me just show you. Let me save this and open Scapy for a moment and just type the ls DNS. Let me just see if it is there. Okay, the DNSRR will be the DNS response, and in the DNS request, DNSRQR, we have the query name, and it even gives the example for it to be, for example, via www.example.com. Now right here can be specified any actual website, doesn't have to be this one. So let us go back to our DNS spoofer. We made the query name, and all we want to actually check right now is whether we have the actual name of the website that we want to redirect in this query name. So for example, in this case, what I will do is I will redirect this website right here. Let me just show you in the page so you can actually check the website itself. the website is actually this one. So what I will try to do is I will try to redirect this website right here. So let me just close this for a second and check if that website name is in the query name. So we can do that if this website name, is in query name. Now once you test this program, make sure to specify the website that is over HTTP, otherwise this might not work. Or you can specify a website that is HTTPS if you're running the SSL strip and if the website is vulnerable to the SSL strip. So any other website that is running over TLS encryption will not work. So for example, if you specified here facebook.com or twitter.com, it would not work. So what we want to do right now, if this name is in our query name, that means the user actually specified this in their browser and they want to browse for this actual website. But we want to actually change the answer from that website and change the query name to be the IP address that we want to redirect them to. So we will make a variable called answer, and that answer will equal to this kp.dnsRR, which stands for the response, and the RR name, which is a field in the DNS response, so let's specify it, will be equal to qname, and the R data. So what we are doing right now is basically we are intercepting the request from the user and then we are sending our own response back. And the R data will be equal to the IP address of my Kali Linux machine, which is 192.168.1.9, which hosts the fake Facebook page. So let me just run the Apache 2 on my Kali Linux. Apache 2 start. Now once again, in order to start Apache 2, you just need to type service Apache 2 start, and what this will do is it will start the Apache 2 web server for you. So let us go back to our program, since that is something you should already know. And what we want to do right now is actually in the DNS packet change the AN field, which I showed you right here. So if you just type ls-dns, you will have the AN field, which is basically the answer. We want to change it to be the answer that we right now specified or changed. So let us do that. Let us make that to be equal to the actual answer that we coded right here from this variable. So skp_packet, the field from skp.dns, and then the field from the DNS, which is AN, will be equal to our answer. And we want to also change the number of answers. So sometimes some website page can have multiple answers, and sometimes the DNS response will send all of those answers back. For example, you can access, for example, Facebook on different IPs because there are more servers, and then the DNS response will send most of these answers back to the user. What we want to specify is that the number of answers will only be one, which is the one that we specified, and we can do that with this command. So skp_packet, the field skp.dns.an count, which stands for answer count, will be equal to 1, which, as I said, specifies the number of answers to be equal to 1. And all we want to do after that is actually set the skp_packet at the end to be equal, or not to be equal, we want to actually send the packet, or before we send it, we want to set the payload that we actually made right here. Or let me just delete this, so it's not the skp_packet, as we can see right here, we are processing packet, and we just named this skp_packet, which only has this payload. What we want to do is set the packet variable, or the packet, and set the payload with this function right here, to be equal to the string from this skp_packet. So what we did right here, we took a normal raw packet, you took the IP field, we took the gate payload from that IP field, we checked or changed the DNS response, we set back the payload to be our changed DNS response, and what we will do right now is we will actually, let me just go right here, we actually want to send the packet. In order to send it, you just type packet dot accept, and what this will do is it will forward the packet that we actually changed in this function. But before we do that, we actually want to change a few more things, since if I show you right here, if we go right here, let me just check this out. Open up my escapee and ls the IP header. You can see that the IP header, which is a must header for the actual DNS request and response, has some fields called length and the checksum. What these fields do is basically they check the length and the size of this packet, and then they send the packet back to the actual user. Now, if the length and the checksum are actually different from the actual packet size, this packet will get dropped and our packets will not work. This is a security measure, so the user can make sure that no one interfered with the actual packet. So the packet will get dropped in case the length is not equal to the length of the actual packet. So what we need to do is actually delete these two fields from the actual packet that we are sending back to the user that we actually changed. But we will do that in the next lecture. For now on, we just change the packet. All we want to do in the next lecture is make a function which will delete unnecessary fields in our escapee_packet. So hope you enjoyed this tutorial, and I hope I see you in the next one, where we will actually test our DNS spoofer and where we will do some of the minor changes to it. Hope you enjoyed it, and I hope I see you in the next tutorial. Bye!